Here are the homework answers for section 9.6 on empirical formula calculations from page 241 in your book, numbers 19 and 20. So I will show you the answers here. If you need to pause the video, do so. After you are done checking your homework and fixing any mistakes, then you can submit your notes and your homework. So that was problem 19. Here is problem 20. Here's part A. And here is part B. So if you had any problems with those, I will go through how to do those problems with you now. So problem 19 says, aspirin is the common name for acetylsalicylic acid. If 100 grams of aspirin contains 60 grams of carbon, 4.480 grams of hydrogen, and 35.53 grams of oxygen, what is its empirical formula? So to start this problem, we just take the mass amounts that they gave us, so 60.00 grams of carbon, and we change that to moles, and we know that 1 mole of carbon from our periodic table is 12.01 grams of carbon. When we cross out our units, we know we did it right. Remember, the units have to cancel. And I get 4.996 moles of carbon. For hydrogen, I have 4.480 grams of hydrogen. I know from my periodic table that 1 mole of hydrogen is 1.008 grams of hydrogen. I make sure I can cancel my units so I know I set it up right. And I get 4.516 moles of hydrogen. For my oxygen, I have 35.53 grams of oxygen. I know from my periodic table that 1 mole of oxygen is 16.00 grams of oxygen. When I do the division, I get make sure I cancel, 2.221 moles of oxygen. Now, looking at all of these, I have 4 significant digits for everything. Let's go and figure out our mole ratios. So what I will do is I will divide all of these numbers by the smallest number, which is 2.221. So carbon, I divide 4.996 by 2.221, and I get 2.249. For hydrogen, I divide 4.516 by 2.221, and I get 2.033. And for oxygen, I divide 2.221 by 2.221, and I get 1. Now looking at these, I cannot round this number. But this number is the same as 2 1/4. When I write that as an improper fraction, I get 9/4. So what I do is I multiply, to get rid of that denominator, I multiply all of these by 4. When I multiply by 4, I get 9 for this one. I get 2 times 4 is 8 for hydrogen, and I get 4 for oxygen. Therefore, my empirical formula is C9H8O4. So that's how I do problem 19. For problem 20, the problem reads, lidocaine is a widely used local anesthetic. A laboratory analysis of lidocaine reveals that a 5-gram sample of lidocaine contains 3.588 grams of carbon, 0.473 grams of hydrogen, 0.598 grams of nitrogen, and 0.342 grams of oxygen. What is the percent composition of lidocaine for part A? And B, what is the empirical formula of lidocaine? So first for the percent composition. So this is for part A. Let's start with our carbon. They give us the numbers in grams. So I have 3.588 grams of carbon over the mass of lidocaine, which is 5 grams. And I'm not going to write out lidocaine. Times 100%. When I do the division and the multiplication, I get 71.76%. For hydrogen, they give the mass to me for hydrogen of 0.473 grams. I divide that by the mass of lidocaine, which is the whole, because this is the part over the whole, times 100%, and I get 9.46%. For oxygen, the mass of the oxygen is 0.342 grams of oxygen. Divide that by the total mass of lidocaine, multiply by 100, and I get 6.84%. And for nitrogen, I have 0.598 grams of nitrogen. Divide that by the 5 grams for the lidocaine, times 100, and I get 12%. So that's how I find the percent composition. Now let's go ahead and find the empirical formula for part B. Now there are 2 ways to go about this. You can use the masses in the problem, or you could use the percentages and just say that they're grams to find the moles. I'm going to use the numbers in the problem because that's the safer bet, just because now there's always partial credit on these things, but if I made a mistake in my percent composition, that mistake could carry through. So if I go back to the original numbers, I don't have a mistake that I can carry through. So I'm going to go back to the original numbers and show you that way. If you do it the other way with the percentages, we should come out with the same answer as long as your percentages are correct. So using the original numbers for carbon, 3.588 grams of carbon. I have to convert that to moles. I know that 1 mole of carbon from my periodic table is 12.01 grams of carbon. Remember, I'm rounding those numbers to 4 significant digits just so I don't have to write so many numbers. So I get 0.2988 moles of carbon when I do the division. Make sure your units cancel so that you know you're doing everything properly. For hydrogen, it's 0.473 grams of hydrogen. I know that 1 mole of hydrogen is 1.008 grams of hydrogen. When I do that division, I get 0.469 moles of hydrogen. For my oxygen, I have 0.598. Oh, I'm sorry, this is nitrogen. Nitrogen, I know that 1 mole of nitrogen is 14.01 grams of nitrogen. And when I do the division, I get 0.0427 moles of nitrogen. And last but not least, for my oxygen, 0.342 grams of oxygen. I know that 1 mole of oxygen is 16 grams of oxygen. That cancels. And so when I do the division, I have 0.0214 moles of oxygen. Now the next step is to look and see which one of these is the smallest number. That is my oxygen. So I'm going to divide all of these by the number of moles of oxygen. So for carbon, I'm going to divide 0.2988 by 0.0214. And I'm just going to round these right off if I can. I get a number that can be rounded off to 14. For hydrogen, 0.469 divided by 0.0214. That rounds off to 22. For my nitrogen, I have 0.0427. Divide that by 0.0214. That rounds off to 2. And for oxygen, I divide it by itself. So I better get 1, right? And I get 1. So my empirical formula is C14H22N2O1. Oops, I never write ones. Whew. So that is how your homework problems are done. If you have any questions, write me comments, email me, text me, call me. I'm there. So I'll see you next week with some more videos. Bye.